Whenever we're talking about solutions, one thing that always comes up is how concentrated the solution is. And concentration is basically a measure of how much things are dissolved in the solvent. So how much solute is in the solvent. And that's what we mean by the concentration. If it's very concentrated, then that means there's a lot of solute in the solvent. If it's not as concentrated or dilute, then there's very little solute that's in the solvent. Now, there are two ways of determining properties in science, and that is whether it's a qualitative or quantitative. And we could do the same thing with concentration. And so qualitatively, we can sometimes look at solutions and determine whether it is concentrated or not by looking at the color. So a good example would be Kool-Aid. So if you're making some Kool-Aid, which is just for those of you who don't know what Kool-Aid is, it's a powder mix that you mix in with water, and usually it's colored and has different flavors like lemonade and fruit punch and things like pink lemonade, things like that. And so there's always a colored solution. So if you have Kool-Aid, if you put lots and lots of the Kool-Aid powder into a little bit of water, you'll notice that it's very dark. And so that means it's very concentrated. If you don't put that much powder into it, then it's going to be very light in color, and so it's not going to be as concentrated. It's going to be dilute. And so that would be a qualitative description of concentration. Now, another way, more I guess technical way of describing a qualitative property of solutions is saturation. Saturation means that we can't put any more solid in or any more solute in. So if something is saturated, that means it's completely filled up. So a saturated solution means that there is no more solid that can get dissolved. And the best way to determine whether or not a solution is saturated is if you see some solid on the bottom that has kind of settled to the bottom. That means that there's no more solid that can go into that solution. That solution is saturated. Now, if you can put more solid into it, then that's what we call an unsaturated solution. That just simply means we can keep adding more and more solid. Now, there comes a time when you can actually make something what we call supersaturated. So remember, if you increase the temperature of water, generally you can add more solute to whatever you're adding. And so if you increase the temperature of the water, that means you can put more solid, or more solid can dissolve. So if you're at a higher temperature and you have a saturated solution and you lower that temperature, then we have what we call a supersaturated solution. That means that at that particular temperature, there can't be any more. In fact, we have too much stuff dissolved in. And a lot of times, if you just add a little bit extra to a supersaturated solution, you will see all the extra solute that shouldn't be dissolved just come right out of the solution and settle to the bottom. And then at that point, it becomes a saturated solution. So supersaturated solutions are made by heating up your liquid, getting as much of it dissolved in that liquid at a higher temperature, and then cooling it off to a lower temperature, and then it becomes supersaturated. So those are what we call qualitative determinations or qualitative properties of a solution. Now, what about the quantitative? Quantitative deals with numbers. And so there are kind of two ways of describing concentrations quantitatively. One you're very familiar with, you've used pretty much throughout your entire academic life, and that is a percentage. And so what exactly is a percentage? Well, basically a percent is simply the part over a whole times 100. That is what we mean by a percent, is a part of something divided by the whole amount times 100. Now, when dealing with solutions, we can think of these parts and wholes based off of mass or volume. And depending on how we're calculating those parts and whole, we can have different percentages. So if you're calculating your part based off of mass and your whole based off of mass, then we call this a mass percent. So a mass percent, and I'm going to use a symbol for percent, is simply the mass of whatever part you're looking at, which is usually the solute, So a lot of times that is what we're talking about, what's being dissolved, divided by the mass of the solution, which is the whole amount. Remember, a solution is made up of both the solute and the solvent. So if you're given the two masses, a solute and a solvent, then you have to add those together to get the mass of the solution. And so a lot of times we abbreviate this as an m/m, as a mass percent. Now the other way of looking at percentages is by incorporating volume, because remember, we're dealing with liquids, and so liquids, usually we measure liquids in volumes. And so we can have what we call an m/v percent, and this is a mass volume percent. And so this would be the mass of whatever your solute is divided by the volume of the solution. And so remember, mass, we're going to measure that in grams, and this time volume is actually going to be measured in milliliters. And so in a mass volume percentage, we're going to have a mass over grams over milliliters as our units for determining this percentage. So let's go ahead and do an example. Let's say we're all familiar with bleach. We probably have bleach in our laundry rooms. And so bleach, the compound in bleach that makes bleach bleach, is something called sodium hypochlorite. Sodium hypochlorite is abbreviated, or has a formula, NaClO. And so this is a chemical formula for sodium hypochlorite. And a lot of times the bleach that you buy in the store is 5%. And this is usually a 5% by mass solution. So that means it's a m/m solution. Now, let's say we have 125 grams of bleach. And we want to know how much sodium hypochlorite we have in 125 grams of bleach. So to do that, we have to look at this 5% and kind of break it up into this part over whole that we have up here, this mass of the part over the mass of the solution. So this 5% simply means we have 5 grams of sodium hypochlorite, divided by 100 grams of solution. And so this is what 5% by mass means. We have 5 grams of our part over 100 grams of solution. So this is 5%. And so here, bleach is our solution. So if we have 125 grams of bleach, we then can use this ratio to determine how much sodium hypochlorite we have. So we have 125 grams of bleach, which is our solution, and we multiply it by this ratio of 5 grams to 100 grams for our conversion to get grams of sodium hypochlorite. And so when we do 125 times 5 divided by 100, we're going to get 6.3 grams of sodium hypochlorite. So if we have 125 grams of bleach, then that means we have 6.3 grams of sodium hypochlorite in this solution. Percentages are, whenever we have a percentage, remember, to get a percent, you have to multiply by 100. So percent, we multiply by 100. Another way of dealing with percentages that are really low, we have a different set of units besides percentages. We have what we call parts per million and parts per billion. So if percentages is multiplying by 100, then a parts per million, which we abbreviate as ppm, is simply multiplying by 1 million. So in a million is 10 to the 6. And a ppb is simply by multiplying by 10 to the 9, or a billion. And so if you have a percentage, we take our part over a whole and we multiply by 100. If we want to calculate ppm, rather than multiplying by 100, we multiply by 1 million. And for ppb, we multiply by a billion. There's also a ppt, which is parts per trillion. And so these are the units that we use whenever we're dealing with extremely dilute solutions, when we're only talking about a very little amount in a large amount of solution. Another way of measuring concentration is by using moles. Now remember, we're in chemistry, so of course moles is going to come into play here. And so remember, moles is the amount of something. Just like a dozen is 12, a mole is Avogadro's number, 6.022 times 10 to 23 thing. And so when we're dealing with moles of solute, we use a term called molarity to calculate our concentration. Our molarity is defined to be moles of solutes divided by liters of solution. Now don't forget, it is liters of solution. Us chemistry teachers love mixing these up and give you problems with milliliters rather than liters, just to see if you will convert to liters. So always convert to liters whenever you're calculating the molarity. Moles of solute, the way we get moles of solute is from the molar mass of the compound, which we get from the periodic table. So let's do a problem here. Let's say we have 45.0 grams of HCl, and that 45 grams of HCl is in 750 milliliters of solution, and we want to know what the molarity is. Now again, remember what I said, this is in milliliters, so we need to first convert this to liters. So remember, to go from milliliters to liters, we divide by 1,000. So this is 0.750 liters of solution, and so we have 45 grams of HCl and 0.750 liters of solution. So next we have to figure out the moles, and so to get moles we use the molar mass of HCl, and so we get that from the periodic table, and so the molar mass of HCl is equal to 36.46 grams per mole. And so if we have 45.0 grams of HCl, then we can then use the molar mass to get the moles. And so since it's 36.46 grams per mole, we have grams, so that means we want grams on the bottom, and we're going to put moles on the top. And so we'll put the 36.46 here on the bottom and 1 mole here. And so when we divide these two, we will get 45 divided by 36.46 gives me 1.23 moles of HCl. Now we have our moles of HCl, we have our liters of solution, we just plug it into this formula to get the molarity. So our molarity, which a lot of times you'll see molarity abbreviated with a capital M, so molarity is equal to 1.23 moles of HCl over 0.750 liters of solution. And so when you divide that, you'll get 1.64 molar, which is another way of saying molarity, solution, a 1.64 molar solution. Now, whenever you're dealing with solutions, a lot of times you buy very concentrated solutions in the store, and you might have to dilute it. And so we have a dilution formula that we use in chemistry. And if you do anything in chemistry in the future, you're most likely going to do a dilution formula. It's one of the things that is used everywhere. And so the dilution formula is a very simple formula. You simply are going to use a molarity, because concentrations are usually always given in molarity whenever you buy from a chemical supplier. You always have something that's concentrated and you'll be given a molarity. And so if we take the molarity, which remember is moles per liter, we take that molarity and we multiply it by a volume. Now let's look at the units when we do that. So when we take the molarity, which is moles per liter, and we multiply it by a volume, and we're going to say the volume is liters, we're going to get moles to be our final units. So if we take the molarity of something and we multiply by the volume, we're going to get the units of moles. So let's think about whenever we concentrate or dilute something. We have a concentrated amount, and what do we do to dilute it? We simply add more solvent. We're not adding more solute to the solution. So simply by adding more solvent, we're not changing the number of moles that are present. We're not changing the number of solute compounds in there. So the number of moles is always staying the same. So if we simply multiply the molarity in a volume, we're going to get the moles. And so if this is our concentrated, that has to equal our dilution. So whatever the molarity is of the diluted times the volume of that diluted has to be the same number of moles that's present in the concentrated. And so we have the dilution formula where M1V1, which could be the concentrated, is going to equal M2V2, and this might be the dilute. And so here we have concentrated and diluted. And so let's do an example here. Let's say we have 265 milliliters of a solution that is 1.2 molar. And so what we're going to do is multiply that by 1.2. We're going to multiply these two together, and that's going to give us the number of moles that are present in this concentrated solution. And we want 700 milliliters. So we want 700 milliliters of a diluted solution, and we want to know what that new molarity is. Now, you'll notice that these are in milliliters, and we multiply these together. We're multiplying milliliters times moles per liter, which isn't very good. So what we want to do first is convert this to liters. And so we got 0.265 liters, and we multiply that by 1.2, and then the 700 is 0.7, and then we have our new molarity. And so we're just using this formula, M1V1 equals M2V2. So this was the volume of our concentrated, the concentration of the concentrated. This is the new volume, and this is what we're going to do is to find the molarity or the concentration of the dilution. So we're going to simply multiply these two together and divide by 0.7. And when we do that, we get 0.265 times 1.2 equals, and divide that by 0.7, and we get 0.454. So our new molarity is now 0.454 molar. That is our new molarity of the solution.